This conference will now be recorded.
Okay. Okay.
Ravi, I checked that dot count operation on the list.
Okay.
So actually, just like we give a condition for filter,
Hmm.
we need to give some condition and it will count the items according to that condition.
Based on the condition. Yeah, yeah, I missed that
Yeah.
part. Very good. Okay, let's see here. So I'll be showing you some of the higher order functions here, which are quite important. We'll be using in the Spark as well. Okay, those functions are. Let's take our list. We have concatenated list 4. What is the list 4? List 4 and list 2. Okay, let's do this. Value list 8 equal to this. Okay, so I'm creating a new list here. Now, if you guys remember, as I shown you in the last session, there are a few methods, right? There are so many methods are there. So if you say like list 2 dot, if you press tab, it will show you some of the methods, right? Here, I'll be talking about a few methods one by one. Okay, let's see. The first one is distinct. I think we have seen this distinct. List 8 dot distinct distinct. SL state. When you do the distinct, it will print only the distinct elements. Okay, and contains those things we have already seen, right? Let's see few of them, like filter. Okay, I think we have seen already a filter, but anyway, let's see the filter again. Filter. Here itself we have. Here itself we have filter. Let me copy this here. Here, take list state. Okay, so what it is does, it filters the elements which is greater than 2, which is greater than 2. Not only this condition, you can pass any of the condition. Okay, let me show you another method. Let's say uh, let me assign the distinct elements to another variable val dist list equal to distinct list I have taken. Now once I get the distinct list, look at here. This is my distinct list. Okay, 1 3 5 7 8 9. These are the distinct list. Now I want to add one to every element. I want to add one to every element. My requirement is I want to add one for every element. Like this is 1, I want to add 1. So 1 plus 1 2, 4, 6, 8, like that. For that, so what you need to do, you have to traverse through each and every element, correct? You have to traverse through each and every element and you have to append the number 1. For that, dist list dot map, what we are trying to do, we are trying to map, we're mapping an element for every element. Okay, here you take element plus 1, element plus 1. What it does, it travels through each and every element. It travels through each and every element. While traversing, it will append the element. It's called mapping. Mapping means you are mapping to every element. First you map it to first element, second you map to second element, third iteration we map to third element, fourth iteration we map to fourth. That's the reason we will call map. Okay. Not only this, we'll see the advanced way in the map methods in the uh, Spark. Instead of writing, we are writing a simple function here, right? Instead of writing a simple function here, you can write some complex function separately. That function you can pass here. Okay, we have written a simple function here, right? You can write a complex function separately and that function can pass here. That's the meaning of the higher order function, right? The function who takes another function as an argument, right? You can do like that. Okay, or you can also do one more thing here. You want to traverse through each and every element and you want to wherever you find even numbers, then you want to increment by 10. That also you can do. For that, you have to write a simple okay. So you want to increment wherever you find the even number, and we want to do something, right? For that, map take element. Here you can do like if element modulo by 2 equal to 0, then PLE into 10. So we want to increment by 10. If you want to write else condition, else you can write as is. Okay, let's do this. You look at here, wherever you find even number, it is incremented by 10. Right? Let me show you. If you want, you can just see the distinct element. You see the dist first. 2 into 10 20, 4 into 10 40, 6 into 10 60, 10 into 10 100, 120, 140, 160, 180. You can see here. Okay. So like this also you can do. This is map. We have seen filter, right? There is something called flat map. Flat map. The flat map is the scenario is different for the flat map. The flat map is, I think we have already seen it. Let me show you. Look at here. Let me copy this. The flat map is, it's also a map. Flat map. Any doubt about the map? Let me ask that. Any doubt about the map? Any doubt about the map? Yes, I'm audible to everyone.
Yes, Ravi.
Okay. Any questions about the map?
No, we are good.
So your flat map also a map. Flat map also map, but what it does, your map, try to remember, this is the most important interview question. Most important interview question. People will ask an interview. What is the difference between the map and flat map? Okay. Map, what it does, it takes one element, it returns you one element. It takes one element and it returns you one element at a time. In one iteration, take one element and returns you one element. That's called mapping, one-to-one mapping. We'll call it as a one-to-one mapping. But flat map is not like that. Flat map also like a map, but it flattens the things. Flattening. Let's try to understand what is a flatten. Look at this list. You have a names. Try look at the flatten. What it does? Scala, Java, Spark, Kafka, Hive, MapReduce. These are all list of collected elements. List of Scala is a group of characters. Java is a group of characters. Spark is a group of characters. But when you do the flatten, normal flatten, it is not a flat map, it is just a flatten. What is a flatten is doing? The group is broken. The group is becoming broken, flattening. Normally, you have a group of characters as a scala. The scala has been broken into flatten. Are you guys getting what I'm trying to show here? This is quite important. Okay, so really, people will ask an interview like, what is the difference between the map and flat map? So if you have a group, it will break that group, it will flatten it. Okay, so something like, let me show you, will it work or not? Scala dot pattern, it required a collection or group of elements. Single string it will not do. This can be done on like this. So it can done on the list only like this. Right. Yeah. So if you observe closely, flatten what it is doing, it is taking single element broken and returning you multiple elements. Are you guys getting what I'm trying to show here? Yes, no?
Yes.
Yes.
Yes, Ravi.
So it takes single element and returns multiple elements. It's a one-to-many mapping. It's a one-to-many mapping. One-to-many mapping. If you do the same with the flat map, to make you the difference, let's say I'm converting into lowercase. Look at this, what happens. All become Scala, Java, all these things, right? If I do the same thing with flat map, look at this. This is a difference. That is the difference. Okay. Flat map takes the group and broke. It means you take one element, returns iterable of elements, returns group of elements. That's a flat map, one to many. Map is one to one, but flat map it takes one to many. Okay, try to remember this difference. People will ask in interview. Okay, next filter we have already seen. Map, filter, flat map. Let's see, there is something called fold left, fold right. There is something, right? Let's see that. For this, I'll just go with the list distinct elements only. Okay. Before that, try to understand what is those methods, or this fold and or what is those methods and how it they work. Okay. Fold. Find the same way what we have seen. Map, flatten, fold. Okay. Look at here. Folds the elements of this traversable or iterator using the specified associative binary operator. The order is which operations are performed on the element is unspecified and may non-deterministic, right? Let's see this one. Okay. Um, okay. It's not there, right? It's to here. Distinct dot fold fold. Let's see fold left. Okay. Uh, Start the operation from the left side. It will take the initial value and it requires an operation. Okay. Let me show you what I'm trying to show you. Let me explore this. Let's see this one. It's folded everything. It's a folded. Let me show that. Let me make you understand how it works. First, let me print the dist elements. Okay. Look at here, guys. You have 1, 3, 5, 7, 9, 11, 13, and so on, right? Or to make you very simple, is to make you easily understand, I'll do one thing. Val L1 equal to, let's start 1, 2, 3, comma, 6. L1 dot fold left. From left hand side it will fold, nothing else. It will fold from the left hand side. Fold the left, take 0 and like this. Okay. What do you understand here? Underscore plus underscore is nothing but, like last time I have shown you, right? Underscore greater than 2 in filter. Similarly, underscore means first element. First underscore represents the first element, and the second underscore represents the second element. First element and second element. It doing the sum, and the sum will be considered. Then the 5 will be taken in the next underscore. I'll tell you. The same thing I can write in this way. Mm,
Ravi, A, comma B should be in brackets.
but it should work. Just, thank you. Look at here, guys. What this fold left is doing, okay, it takes the first two elements. Now I'll talk about this 0. This is called initial value. This a represents the first element, B represents the second element, like that. Okay, but in the fold left, 0 is the initial value, beginning. Okay, the 0 become A. In this case, okay, 1 second, just Look at here. So it's a 0, right? Here in the first iteration, what will happen? Iteration 1, IT1, A will be 0, B will be 1, B will be 1. So what is the operation I'm doing? A plus B. What is the output? 0 plus 1, 1. Second iteration, iteration 2. Try to remember guys, this is quite important. Iteration 2, A become 1, A become 1. What one? Not this one. This sum. And B becomes 2. This element. B becomes this element. Now what is the output? 3. Now here A become 3, B become 3. Are you guys getting, guys? This is important. You need to understand this, how it is working. Is this clear? Or still you have a doubt?
It's clear, Ravi.
Yeah. So initially A will be 0 and B will be 1. Then it will do the sum because I'm doing the operation sum operation. Then it will give the one value. That value will become 1 in the next iteration. That value will become A in the next iteration. And the second element from the list will become B. It keep on goes like this. Here A equal to 6 and B equal to 4. Now output is 10 like this. Now A becomes 10, B will be 5 like this. This is how that fold left iterate through. Fold left will iterate through. So if we say total sum, it will 55. You should be very careful while choosing your initial value. If it is a plus operation, you can start with a 0. If it is the multiplication, if you start with a 0, it will become, the whole output will become 0. The whole output will become 0. Okay, we should be little careful while choosing this element. While doing a multiplication, choose 1. While become this, you can choose whatever you want. Even if fold also does the same thing. Fold left and fold. There is something called fold right. It does from the right hand side. Okay, it does from the right hand side. I think I should have that examples in Spark. I think not here, but anyway, we'll see in detail about while discussing Spark. In Spark, I have a specific methods I have written. I will show you that. Okay, is this clear about the fold left, fold right? It is folding. You can go with whatever the, suppose let's take a starting element. I will take here 1. You can see 1 plus 1 2, 2 plus 2 4, 4 plus 3 7. So it will become 1 increment. Similarly, if you take 10, it will be based on that only. Okay. So in the same way, we have something called reduce. You can see here the methods: fold left, fold right. Okay. Group by we'll see group by, reduce by, group by key, reduce by key. These things we'll see in uh, Spark. Okay, so same methods only. They're also the functionality same. We have seen is empty. We already checked last element. We already seen iterator. We already know. So max we did, min we did, max by, min by, string. These are all we'll see in the Spark. Okay. Partition also we'll see in Spark only. Reduce, reduce left, reduce right. These are also same way, the fold left and fold right. But it will not take any initial value. Let's see this. Same. Reduce left and reduce. They will the fold left. They will take initial value, but reduce left. They will not take the any initial value. You can do with reduce also. It will not take any initial value. That's the difference between the fold left and fold right, fold left and reduce left, fold and reduce.
Ravi, what's the difference between fold and fold left?
Fold and fold left both are same. You're
Okay.
specifically specifying the left hand side, nothing else. Look at, you can see here. Applies the operator of the start value and all elements in this traversal iterator going left to right. That's the only difference. It's also by default it goes left to right only. By default it goes left to right only. But explicitly we need one method. It says that you're starting from left. So that's a fold left they have. Fold left and fold right. You can see fold right. You're specifically specifying here. So it's the right hand side or left hand side. Okay. Any other questions? These are the methods I thought to cover. And reverse we already seen. Okay. Tail we have already seen. Start with, we'll specify starting with which element. To map, to list. Yeah, to list you are converting into list. To map you are converting into map. Okay, these things we will see. To sequence you are converting into sequence. To set you are converting into set. These are all the methods which come from the parent session, a parent class, a parent trait I can say here, parent trait I can say here. Okay, zip I'll tell you, zipping. Let's say I want to zip with one element. I have a you want to zip with one element. For every element, we will use a zip function. Let me show you that how it looks. Let me show you. One second, let me, I forgot where I have written that. It's not the Yes, it's the most right. I think I have explained on console here. No problem, I'll show you. Zip with index, zip with index ID. Let me show you this. But you should know what is a PRDD, both RDDs, right? Let me show. I'll do one thing. I know this will not available. The fruits and zip lengths are not available, right? Let me take one thing. I have a L1. Let me take a L2. List of, I'll go with only even numbers. Okay. Now L1 dot zip L2. L1 dot zip L2. So it means when I zip with, I mean appending, I like clubbing. You have one element from one list, take that. You have one element from other list, club it. So like that it is zipping. And also if you see, I have L1 has a 10 elements, L2 has only 5 elements. The final output you got only 5 elements. If you do the reverse, look at it. How many elements you have, it is taking only those many elements. The rest all, if there is no element for zipping, it will not consider it. It's a zip, it's like clubbing two elements. Clubbing two elements. Take this. If you guys have any doubt, please ask me. Any questions? Dot zip. It prints like this. You can do other way. Println L2 dot zip. Hello. So now I'm doing with another list, right? In the collections, if you in the Spark, if you go with it, you have zip with index, zip with it, zip with the unique ID. There are different other options also there. Anyway, those we will see when it comes. Yeah, these are the most of the methods which I want to cover. These methods will call as a higher order functions. Zip with index, zip all, zip with unique ID. Okay, so we will see those methods. The other rest of other methods in the Spark. Any questions? Tomorrow we'll start with set. Set is quite simple. Once you understand the list, set is not that much difficult. Set help you to avoid the duplications. There is let me give a simple introduction for that. List actually has the index and it maintains the insertion order and it will allow the duplicate, correct? Set is quite different for that. Set will not have set will not have an index, set will not maintain insertion order, set will not allow duplicates. Set will not allow duplicates. Okay. Set is unique collection. Set is unique collection. Okay. We will see. We'll see about the set in the next session. The same methods. The methods and all I told you, right? They are all coming from parent. So methods will be same, but the behavior of the set is different. The behavior of the set is different. It won't maintain the index. It won't maintain the insertion order. It will not allow the duplicates. It will not allow the duplicates. The methods are same. We'll discuss in detail the set in the next session. If you guys have any questions, please ask me. Else we can leave for the day.
Yeah, Ravi. Actually, can you please repeat the difference between flat and map and flat map?
Yeah. Okay. Map, what it does? Map, it take one element and applies the functionality on that element. Correct? It takes one
Correct.
element and applies the functionality on the one element and returns one element only. It will not return multiple elements. It will not return multiple elements. Let me put it here. You have a list like this. Okay. Map, what it does, as part of the map functionality, we will write like this. Increment by 10 or some functionality you'll write. What it does, it takes the first element into 10. Correct?
Correct.
Take the first element as a part of the first iteration. Take the first element into one element. So what will be the output of this? Output of this?
It will be 10, 20, 30, 40, 50, 60, like that.
No. First element. It's
Yeah.
iteration 1. It's iteration 1, right? Iteration 1, it will be 10.
10. Yeah.
So 10 is a single value or a group of value?
Single value.
Single value, right? Similarly, iteration 2, what it does? Same it will do. What it does? It will take 2 bracket 2 into 10. It return you 20. It's also single value.
Yes.
It means what your map is doing, it taking one element, returning one element. Right? What your map is doing? Taking one element, returning one element. Correct?
Yeah.
Okay. Now, coming to, let me take an example of the list. Okay, here I'm doing a flat map. Here, when you apply the flat map functionality, like uppercase to upper, or if you simple apply the flat map, what it does, as part of the first iteration, iteration 1, it takes scala, complete scala, correct? Yes or no?
Yes.
And after applying the functionality here, it returns collection, group of elements. It returns a group, like is this a group or not? This is a group.
Okay.
So it means your map function is taking one element and returning one element. Your flat map is taking one element and returning a group of elements. That is the difference. It flattens the things. It broke the things. When I have a single group, it will break, it will make it as a multiple elements. We'll normally call iterable of elements. Iterable of elements. That's the thing. If you see, flatten, flat map. Look at here. Builds a new collection by applying a function to all elements of this iterable of collection and using the element of the resulting collections. So if you take an example here, splitting, it's actually splitting. Line means you take one complete line, whatever the line, some line you take. When you apply the flat map, what it does, it breaks the elements and returns you group of elements. I think you will understand more detail when we discuss about Spark. If you have any confusion now, but I'll make you understand in more detail.
Okay.
Okay. Any questions? Any questions? Okay, so that's it for now. Let's connect tomorrow. We'll discuss about set and map. I think by Wednesday we'll start Spark. I'll check for if any of the pending topics in Scala. If I feel nothing is there, most of things we cover, then we'll jump into Spark. Any questions, guys? Okay. Thank you. Thanks for your time. Have a wonderful day. We'll connect in the next session.
Thanks, Ravi.
Thanks, Ravi.
Yes, bye.